Hi and welcome to this Transition Year Higher Level Maths Algebra Revision Module video. This revision module has been set up to help you to revise all the algebra topics from the Junior Cert Higher Level course and to help you as you move into the Leaving Cert Higher Level Maths course. This video is looking at simultaneous equations. So we're going to focus on a few different methods of solving simultaneous equations with two variables or unknowns, and these are the elimination method, equating like variables, substitution, and graphically. The last type are going to be simultaneous equations containing fractions, which we're also going to solve using elimination. So let's take a look at example 1, which is solving a system of simultaneous linear equations with two unknowns using the elimination method. So solve the following equations for x and y. If you take a look at each of those equations, the first one being 3x plus 6y equals 54, and the second being 2x plus 3y equals 29, we wouldn't be able to solve either of those equations on their own because of the two variables. So what we're going to use now is called the elimination method, and to start we put one equation over the other. Just like this method is known, our aim is to eliminate one of the variables. It doesn't matter which variable you eliminate, both will give you the same answer. However, my advice is to take a look and see what will be the easiest for you to eliminate, and when I say easiest, it's going to usually be the least amount of calculations. So in order to eliminate the x, we would have to get the coefficient of x to be 6. So that would mean multiplying the first equation by something and the second equation by something. If we were to eliminate the y, we can get the coefficient of y to be 6. So we wouldn't have to do anything to the first equation, and for the second equation we could just multiply it by 2. So this is what we're going to do. So we're going to multiply the second equation by 2 to get both of my coefficients to be the same, but because I want them to eliminate, I want them to have the same number but with different signs. So I'm going to actually multiply across by a minus 2. So my first equation doesn't change, goes 54. My second one is going to multiply by minus 2. It's going to minus 4x minus 6y, and we get minus 58. Now you can see, hopefully at this point, that those y's eliminate, and we get minus x is equal to minus 2. Therefore, x is equal to 2, dividing both sides by minus 1. So that gives us our value for x. We then can take either equation. I'm going to take equation 1, and 3x plus 6y equals 54. And we're going to substitute in, instead of x, I'm going to sub in 2. So I get 3 times 2 plus 6y equals 54. So 6 plus 6y equals 54. 6y equals 54 minus 6. 6y equals 48. Y is equal to 48 divided by 6. So y is equal to 8. So our two values are x equals 2 and y equals 8. One last tip for simultaneous equations: I'd always advise you to write your answer in the form of a point. We'll discuss this in a later example in more detail, but when we are solving two equations, if we were to talk about that graphically, what we're looking for is the point of intersection. What I find is if students write this as a point, that with the x part and the y part, then they are less likely to do something like forget to sub in to get the second variable. Now let's take a look at a different method we could use to solve simultaneous equations, and this is called equating like terms. So look at our equations here. Y is equal to 3x plus 4 and y is equal to 2x plus 10. We could very easily use our elimination here. However, if you notice, both of our equations are given as y equals this and y equals this. So if y is equal to 3x plus 4 and y is also equal to 2x plus 10, by our logical reasoning, we could also say then that 3x plus 4 must be equal to 2x plus 10. So this is equating like terms. So we're equating the y's. So the value for y from the first equation and the value for y in the second equation. So now we just need to work with this. So first of all, we're going to subtract 2x from both sides. So I get 3x minus 2x plus 4 equals 10. Cleaning that up, I get x. And I also want to subtract a 4 from both sides. Get 10 minus 4. And we get x equals 6. Now we can go back to either one of our equations and substitution. So we're going to work with y is equal to 3x plus 4 and sub in y is equal to 3 times 6 plus 4, y is equal to 18 plus 4, y is equal to 22. Just like before, what I would advise is for you to write this in the form of a point, 622. And that's a great habit to get into to make sure you don't forget to go back to sub in to find that second variable. So now let's take a look at example 3. We want to solve the following simultaneous equations and we're going to use substitution. So substitution is suitable if you're given one of your equations with the variable written in terms of the other variable. So in this case, for equation 2, we have y written in terms of x. So what we're going to do is we're going to take equation 1, which is 2y is equal to x plus 1, and we're going to substitute in, instead of our y, we're going to sub in 4x minus 10. So that's coming from equation 1 is equal to x plus 1. We multiply that out, we get 8x minus 20 is equal to x plus 1. We're going to subtract an x from both sides. Minus 20 equals 1. So that gives us 7x minus 20 equals 1. And now we're going to add a 20 to both sides, which gives us 1 plus 20. So 7x equals 21. Dividing both sides by 7, we get x equals 3. So just like before, we're going to go back to either equation. I'm going to take equation 2 because there is no coefficient of y, so it'll be a little bit easier to work with. So y is equal to 4x minus 10 is 4 times 3 minus 10, which is 12 minus 10, which gives us 2. And that gives us the second variable, which is y. So just like before, what I would advise you to do is write this in the form of a point so you never lose any of the variables, and this will help as you move into the harder questions that you see at Leaving Cert higher level. So example 4 is if we were talking about two linear equations, how would we solve them graphically? So we're going to link a little bit to coordinate geometry of the line here. If you have your log tables, you can take a look at page 18, and on page 18 there is a formula for the equation of the line, and that formula is y equals mx plus c. And the letters, what they stand for, m is your slope. So my slope of this is 3, and c is what's called the y-intercept. So it's 0, 4 is where that line crosses the y-axis. Similarly here, my slope is 2. Okay, so the number just in front of the x. And my y-intercept is 0, 1. So based on that c. So when I have linear equations, I know two things very quickly. I know the y-intercept and I also know the slope. You could also work out a second point depending on how you like to plot these. So let's find the x-intercept, or where it crosses the x-axis. So what we're going to do, we're going to let y equals 0 for both of these and see what happens to get us another point. So I'm going to have 0 equals 3x plus 4, so I get 3x equals minus 4, x is equal to minus 4 over 3. Not a great point, it's not going to be very nice to plot, but we can do it. 2x plus 1, so 2x equals minus 1, x equals minus a half. So while you're drawing this, if you take a look at it, you might want to space these out so that you have 3 or 6 spaces between each of the units so you can draw this accurately. So our points in this case is minus, I'm going to write it 1 1/3, 0, just so you have a better sense of where it is on the axis. And this is minus a half, 0. So you can always draw your line using the 2 pieces of information we got initially, so the slope and the point. Or if you prefer, you can use 2 points, which will be this point here, and the second point, and this point here, and our point. So you would draw out your x and y axis, and you would graph it, and what we should hopefully see is something like this. Okay, so you have your 2 lines here, which have been plotted. So I have one in green and one in red, and what I'm going to do to make it a little bit clearer, and what you should always get in the habit of doing, is label each of your lines. So the green line is y is equal to 3x plus 4, and the blue line is y is equal to 2x plus 1. So we're trying to solve this equation. So what we're actually doing anytime we solve a simultaneous equation is we're trying to find the point of intersection. So if we take a look at this graph, we have to see where do the 2 lines intersect or meet. And it happens at that point there. And that point, if you read from your axis, is actually minus 3, minus 5. Now, a lot of people find the drawing very cumbersome to do, but this is a great method if you already have a graph in the question. So it's not something to forget about. Sometimes a question will specify using your graph, find the point of intersection, and sometimes the question might say verify that algebraically, which would mean using any one of the other 3 ways that we looked at, which were elimination, equating like terms, and substitution.